Hello wonderful person, this is Anton, and in today's video we're going to be talking about this unusual binary system known as Cygnus X-3. You can see it kind of changes colors and luminosity once in a while, and you may actually realize that it's a binary system that has two very unusual objects orbiting around one another. Let's find out what they're all about and recreate them using Universe Sandbox Square. Welcome to What the Math. And what you're looking at right here is a slightly darker version of this binary system. So this is essentially the system known as Cygnus X-3. It's one of the brightest X-ray sources in our galaxy. It's basically a source of mystery for many scientists because some of these emissions are so powerful that we don't really even know what is actually going on here, but we have some ideas. Now, if you guessed that this is a black hole, you're not entirely correct because this is actually not a black hole. This right here, in what you see in the background, I'm going to actually zoom out for a second just to show you how large this object is and also possibly return the luminosity to its original value. So close your eyes for a second and boom, it's super bright. This is a wolf-rayet star. Wolf-rayet star is an extremely enormous type of a star that is very, very unstable as well. And I've talked about this concept previously. You can check out some of the previous videos where I actually describe specifically what this actually is. But this wolf-rayet star has this very, very, very compact and dense object that is very likely to be a neutron star orbiting around it every 4 or almost 5 hours. So one orbit here is actually very, very, very fast. It's 4 hours and 47 minutes. If I were to accelerate time, you would see how fast it is just by looking at this sort of an animation. So there you go. So this is the wolf-rayet star, and this is the potentially a neutron star that orbits around it. Now, as you can see, if you can kind of look closer, the actual larger star, it's sort of attracted to this neutron star. Not attracted per se, but it's actually tidally locked to it. And the neutron star is currently absorbing quite a lot of various mass and material from this large star, and basically is stealing most of it and is creating a lot of various energy from it. If I were to actually look at the mass of this right now, it's close to about 39 masses of our sun. Whereas this neutron star is only about 2.5 masses of sun, but it's constantly eating up a lot of the mass from the star, and it kind of sort of creates a very, very unusual teardrop-like shape that possibly is sort of coming out of here and is dragged inside of the neutron star and then creates the accretion disk around it that you'll see in a second as soon as I zoom into it. And you'll see accretion disk orbiting around it, which is basically created by the absorption of the material from the wolf-rayet star near it. And so notice how small this object actually is in comparison to the wolf-rayet star. This is how tiny it is. And there is the accretion disk orbiting around it, and there is that humongous wolf-rayet star in the background. Now, the interesting thing about this particular object, and I'm actually going to slow down time here a little bit just so you can see the accretion disk in more detail, is that, well, first of all, we've detected some of the most powerful emissions from here. So this is what actually is going on here. This is the neutron star, very, very dense, very bright object that is actually going to create quite a lot of interesting effects if I try to land on it. So there is the universe and the galaxy as it appears from the surface of this neutron star. It actually is all squished and condensed and basically curved into one little window. This is essentially what it would look like if we were to stand here. And this is with an actual luminosity, and you can see everything is actually blue shifted because the space-time curvature here is so dramatic that basically not only is the time frame here is very different, and basically you're technically traveling through time if you're standing on the surface here, but you also get to experience very unusual Doppler effects, and of course the entire universe is essentially a small window. So you actually don't even see the world in 3 dimensions. You just kind of see the small window around you. But anyway, so what exactly would we classify this object as? Well, it's technically classified as a micro-quasar. Quasars are a concept I've covered previously as well. You can check them out in one of the previous videos. But This microquasar is called that because it's actually so energetic and so powerful that it produces just as many gamma rays, just as many X-rays that a quasar would, or basically a very, very active black hole that absorbs a lot of material and then spews it out from two directions, sort of up and down. We're going to recreate this in Universe Sandbox in a second, but let's just look at this beauty in a little bit more detail in Space Engine first. Now, this is actually not the most famous Cygnus objects. The most famous Cygnus object I've talked about previously, it's called Cygnus X-1. That is actually a black hole orbiting another very massive star. But this object, Cygnus X-3, is more mysterious. As a matter of fact, some scientists think that it's not actually a neutron star, but might be something more theoretical, like a quark star, which we don't really know much about. It's a star that is not made up of neutrons, but made up of even smaller particles or subatomic particles known as quarks. But I guess what's really, really interesting about this is that this is actually one of the most luminous, one of the most brightest objects in our galaxy. This is why I had to decrease luminosity so much so that you can actually see it without going blind. It is so luminous, in fact, that we often see this over other objects, including, of course, many of the brightest large stars out there. And so essentially this is a very, very interesting, very unusual object. But what I wanted to do in this video, I actually wanted to see if we can recreate this from scratch, because this wasn't always a neutron star. This was once a large star that eventually went supernova and created this object. And so we're going to zoom out of here slowly, and we're going to move away from this system and then go into Universe Sandbox 2 and try to recreate this from scratch. So notice how tiny it is in comparison to this massive wolf-rayet star. It's just a little dot, a little speck right there. So anyway, let's slowly return its luminosity to its original value. Maybe increase the actual orbital speed as well. And here we go. Alright, so let's go to Universe Sandbox and recreate this. And so let's actually recreate this from scratch. We're going to go into stars here and add two really massive stars. Let's choose the biggest ones we have. Something that actually may seem like a wolf-rayet star, like for example Eta Carina B, and possibly a slightly smaller star that would very likely become a neutron star if it went supernova. Like for example, let's just go with Spica. So we're going to place them in orbit around one another. And here we're going to choose binary balanced motion orbit. Let's just place it right here. And I think maybe this is actually not close enough, or one of these stars is actually a little bit too large, because currently the orbit is about 2.18 days. So I'm going to have to decrease the size of this star, I think. And we're also going to rename these two stars. This is going to be Cygnus Partner, and this is basically Cygnus X-3. So this is maybe a few million years ago, when both of them were very large stars. And then, for one reason or another, this star either lived off its life and went supernova, or possibly lost some of its mass and rubbed off against this star and basically went supernova. And what happened was this. So we're going to enable realistic mode here. And we're going to try to cause it to go supernova. So maybe if we do this, there we go. All right. Oh boy, it's too large. This is way too large. Here we go. So supernova has occurred. This was a few million years ago. It already has dissipated. So it's technically invisible to us. But what remained behind was what we would call a pulsar. So we're going to actually make pulsar from this. There you go. There's our pulsar. And we can possibly even change its orbit to make it orbit a little bit closer, although I think these parameters are already locked, so maybe we can't do that. So there is our pulsar, known as Cygnus X-3. Now we're going to wait for this supernova to dissipate so that I can actually show you what is happening here. And we're also going to increase its magnetic field by about 10, because it's a very powerful pulsar. So let's wait a few thousand years. We're going to accelerate time here, making these guys orbit around one another. And with time, this supernova will actually dissipate and disappear completely. Although I just realized it's actually going to be really hard for me to wait for this to happen, because if I accelerate time a little bit more, all of this binary system will actually collapse and I'll probably end up losing both stars. So we might have to do this without making the supernova disappear, and just kind of go through the idea of what's actually happening here. So let's zoom into the system here. We're going to actually take a look at Cygnus itself in a little bit more detail. So this right here is the neutron star that you saw a few minutes ago in Space Engine. It's very, very, very bright, very, very powerful, very, very dense as well. Around it, there is going to be a kind of an accretion disk. Unfortunately, it's not present here, but we can actually manually create it by going into the ring system here and choosing a ring system with a few radii to orbit around this, right here. All right, so this didn't actually work for some reason. I think I'm pointing at the wrong object. Let's try this again. Maybe this will work. So maybe this actually has worked, but all right. So this seems to be some kind of a bug because I was trying to create this ring, but unfortunately it flies away really, really fast. And I think it might be because of the supernova. Supernova might actually be dragging things out of this system right now. So this is why it's impossible to create anything that is stable. But anyway, let's just imagine there is actually a kind of accretion disk orbiting around this. And what we have, because of this accretion disk and because of the proximity to such a massive star, is essentially what you're going to see right here. So there is that accretion disk that I was able to kind of create finally, and there is that sort of a jet that is propulsed by the accretion disk and by the force of the neutron star, making this a very powerful pulsar. So these two jets that you see going up and down, this is what's essentially pointing at us, pointing at our planet Earth, and occasionally sends ridiculously powerful X-rays and ridiculously powerful gamma rays and so on and so forth. Now, it doesn't seem very powerful from here, but the reality is that it's such a powerful pulsar that I'm going to try to recreate it here. It is actually something like this big. It is causing a tremendous amount of energy to project toward our planet Earth, and some of it is some of the most energetic X-ray and gamma rays we have ever detected. So this is what happens once in a while. There's actually quite a lot of patterns we've discovered. There's one that's like about 370 days or so. Every 370 days, there's actually a huge amount of energy that's released toward our planet, and we detected it with the various satellites. And so this object is known for these patterns. And they're also known for being extremely violent events. So violent, as a matter of fact, that it's kind of dangerous to basically be in that particular spot if they actually do occur, even though this object is something like 27,000 light years away from us. Or I believe it's actually 23,000 light years away. 27,000 is the other one called Cygnus X-1. And so this is essentially how this object was created and what it actually does when it releases energy. And this is what it might look like from a distance. It's still very bright, even if you're really far away from it. Or might even be even brighter than that. Let's actually go into materials here and increase the total power of magnetic field to an even higher value of like something like 20. There we go. So even from a super far away distance, you'll still be able to see Cygnus X-3 really well, specifically in X-ray and gamma ray wavelengths. And so all in all, this is actually a pretty fascinating object. There's quite a lot of mysteries about it, and this together is known as a high mass X-ray binary because there's a binary system, there's a lot of mass involved, and it's definitely known for emitting a lot of X-rays, but also gamma rays. And one of the biggest mysteries of Cygnus X-3 is that we still don't really know what it is. We don't really know if this is actually a neutron star, because some of the emissions we've received are so highly energetic that it might actually be something completely different, some kind of an exotic object we haven't studied yet, and possibly even a quark star. And so that's the essence of Cygnus X-3 and its partner known as V1521 Cygnus, and that's what it's all about. That's all I wanted to show you in this video. Hopefully you enjoyed it, and if you did, don't forget to subscribe, share this video with your friends, and possibly even consider supporting this channel on Patreon. Thank you so much for all your support. Now that we've actually reached 40,000 subscribers, this has now become one of the most active space-related channels out there. So I really appreciate all of your support. Thank you guys. I love you so much. I'll see you in the next video. Game you later, and as always, bye-bye. And let's actually look at this Eye of Cygnus and enjoy its kind of a scary looking emission. Now imagine if you were actually right in the middle of this. You would probably be fried alive. Not a very comforting thought, unfortunately. I'll see you guys later. Bye-bye.